This is for my Calculus 1 Optimization Lab number 2, and I'm going to do a couple problems on here. And my first picture is I have a farmer who wishes to fence off two identical adjoining rectangular pens, each with 900 square feet of area. So this is 900 feet square feet, and this is 900 square feet, okay, of area. What are X and Y so that the least amount of fence is required? So everything's going to be in feet. So I'm going to do my constraint, and the constraint is going to be the area. So you have a couple choices with this. And I'm going to, I know it's the area, okay, because that's what they told us. And then my objective is going to be the least amount of fencing, which is really perimeter is fencing, okay? So let's kind of set this up. So the constraint is I actually kind of did the whole thing to save it up, but you could have done each one separately. So I did the whole thing. So I said my area, my constraint is 2x times y has to equal 1,800 square feet. I just kind of did the whole rectangle. Um, and then when you get all done, I've got 2xy equals 1,800. So I'm going to solve for y, get this all set up for when I do this. So y is going to be 1,800 divided by 2x, or y comes out to be 900 over x. So I've kind of got that set up, and I'm going to plug it in over here. Now my fencing that I have, my fencing equation is I've got an x here and here, and this is rectangular. So I have basically, and oh, there's a y in here, I have 4x's plus 3y's for the fencing. So it's kind of hard to see this one right here, but there is a y right here in the middle, if you will. So this is a y as well. Okay, so I'm going to replace the y of this. So my fencing equation is all in x's, okay? So my fencing equation is 4x plus 3 times 900 over x, or my fencing equation is 4x plus 2700 x to the negative 1. I just moved the x up and got it set, because I do know, we've done a lot of these now, that when I do my first derivative and put it equal to 0, that's going to show me the x, that's going to give me the, what do you want, least amount of fencing. So we're looking for a minimum here. So I'm going to write this here, a minimum. We're looking for a min. Okay, so I'm going to draw my line so I can do my f prime. F prime is going to be 4 minus 2700 x to the negative 2. So I'm just going to write it down here and put it equal to 0, because it just saves us a little bit of time. Then I'm going to cross multiply. So I have 2700x. I just moved x squared over x squared equals 4. Cross multiply, 4x squared equals 2700. X squared equals 675. So if I take the square root of both, x is going to equal radical 675, which comes out to be roughly 25.98 feet. So it's almost 26 feet. All right. Now, before we go any further, remember what I showed you. You have to do your first derivative test. So we're going to do f prime, my f prime bar. And radical 675 is really what the answer is, which is 25.98 feet. So you're going to take this that we have right here. Actually, I should make a prime here, so that's my fault. I get going too fast. This is f prime. So you're going to take this right here, and you're going to try to the left and the right of this. So to the left of radical 675, if I use a number smaller than that, we can say 20 or 10, you'll see that this will be negative. If I go greater than 25, we'll say 30 and put that in here. It's going to turn out to be positive. Okay, and then this actually truly is a minimum. So I know that x is going to be 25.98. So when I do my y is 900 over radical. I just kind of left it that way because it didn't come out really nice, 675. When I put that in my calculator, I got 34.64 feet. And that's what they want to know. What are x and y going to be? And we just did. So I would try some of these and see if you can do them, and you might come up with the same answers doing it a little bit different way. This one's kind of fun to think about. So I have an indoor physical fitness room, consists of a rectangular region. So here's my rectangular region, and with a semicircle on each end. So here's a semicircle and here's a semicircle. So that's half of a circle on each end. If the perimeter of the room is going to be a 200-meter running track, so that's kind of cool. This is a track. So the track is going to come all the way around. So that's a track. So the track is going to be 200 meters. Find the dimensions that will make the area of the rectangular region as large as possible. So this is going to be like a fitness room, if you will, which is cool, which I've been to places that have done this. So this is the fitness areas right here in the center. They want to make it as big as possible and have the track be 200 meters. Okay, so let's do our constraint. And let's do our objective. And the one thing I want to show you that I labeled this with is I labeled this to be D, and I called this X. Well, the X, it's rectangular, so I know this is the same. I called this D instead of Y because it's really the diameter of that circle, and it kind of helps you think of how am I going to set this up. So they said the track is 200. So that's kind of like the perimeter around here. So let's look at what we have. So if I run here, I run an X. I run an X here, and then I'm going to run around. So basically, you're running around a whole circle, which is your circumference. So I'm going to say the track is going to be 2x's plus the circumference of that circle, which is pi times the diameter. So that's why I wrote it that way. And I know it has to equal 200, so 2x plus pi d has to equal 200. Okay, I actually solved for the diameter on this one. So I've got pi d equals 200 minus 2x. You could actually solve for x as well. So the diameter is going to be, or d is going to equal 200 minus 2x all over pi. Oops, 2x over pi, sorry. All over pi. And then what I'm going to do right here is kind of rewrite it and do the numbers here. So I'm going to write it like this. The diameter is, hang on a second, divide the 200 by pi, because that's really a number, minus 2 over pi x. So it's like two terms, but either way is fine, okay? Now my objective is to have my fitness area. So let's do blue for the fitness area. The fitness area is x times d. So I want to do a maximum area. So we're looking for a maximum area, okay, here. And the constraint is really the track, if you will. So I'm going to plug in the D with what I just found here. So I'm just going to plug this in here. I have done it the other way. So sometimes you're going to do the opposite of me. You're going to get the same answers when you're done. So the area equals x times 200 over pi minus 2 over pi x. And I just did that again. I get going so fast. I'm sorry. Let's try this again. Okay. It's going to be minus 2 over pi x. Sorry about that. Now I'm going to distribute that. A is going to equal, okay, so when I do this right here, I get 200 over pi x minus 2 over pi x squared. And do you see why I did it that way? Just so we could see what was going on. Okay, here's where I stop, because now I know in order for me to find the max area, I have to do my, ready? F prime of x has to equal 0, so I'm going to do A prime here. So I have A prime equals, so if I do the derivative of this, this is to the first power, so that's just going to be 200 over pi minus, and this one is going to be 4 over pi x, put that equal to 0. Okay? So when I do this, I have 200 over pi equals 4 over pi x, okay? And I'm going to solve for x. So x is going to be 200 over pi times the reciprocal of pi over 4, or you can divide by that, but the reciprocal is a lot more fun. And when I do that, look what happens. This is cool. Thanks for playing. 200 divided by 4 is going to be 50. And so we're talking about meters, so we know x has to be 50 meters. Okay? Before we go any further, we have to do our a prime bar to make sure that this 50 meters is an actual maximum. When I look at it, I'm looking at this. Remember, I'm looking at my first derivative, okay? So if I plug something less than 50 in there, okay, I get a positive number. So you can graph it if you want. And then when I go over 50, it's negative. So it truly is a max. So I did my first derivative test. So I'm good with 50 meters. So now I know that x is 50 meters. Now I got to find my diameter. And the diameter is going to be, okay, so let's do this over here. The diameter is going to be 200 over pi minus 2 over pi times 50 meters, because that's what we found. So the diameter is going to be 200 over pi minus 100 over pi. So you end up getting our diameter is 100 over pi meters. And I'm just going to leave it like that. We could do the decimal if we want, but we know what they are. So they just said, what is the dimensions? Well, the dimension is going to be 50 by 100 over pi. So the dimensions of this, of the of the weight room or the weight area or the fitness area is going to be 50 meters by, and let me do 100 divided by pi just to see what that comes out to be. So I have 100 divided by pi, and I get 31.83. 31.83 meters. Okay, so that's our answer. I hope this helps.